Hi everyone, in this video, we're going to explore another fundamental concept that is crucial for organizing your code: packages. As your Kotlin projects grow, you'll find yourself creating many functions, classes, and other declarations. Without a proper system to organize them, your code base can quickly become messy and difficult to manage. This is where packages come in. What are packages? At its core, a package is a mechanism to group related declarations, such as classes, functions, and properties, into a single namespace. Think of packages as folders for your code. Just like you organize files on your computer into folders based on their purpose, packages help you organize your Kotlin code logically. All declarations in Kotlin are contained within packages. The primary goals of using packages are: organization, to structure your code into logical units, making it easier to navigate and understand; avoiding name clashes, to prevent conflicts when different files or libraries define items with the same name. Each item within a package has a unique, fully qualified name, FQN. Every Kotlin file can, and usually should, declare a package at the very top of the file using the package keyword, followed by the package name. Let's look at an example. Here, we declare that this file belongs to the package com.tonguin.kotlinbasics.utils. This means our greetUser function now has the fully qualified name com.tonguin.kotlinbasics.utils.greetUser. If you do not declare a package at the top of your file, its contents will automatically go into the default package. For instance, there's no need to declare a package for your main.kt file if it's a simple, standalone program. Kotlin follows certain conventions for naming packages. Lowercase. Package names are typically written in lowercase letters. Domain-based. A common practice is to use reverse domain name convention, like com.example.myproject. File naming. While there's no strong relationship between the file name and the class name in Kotlin, unlike Java, it's a convention that if your file contains a single class, you should name the file the same as your class. If it contains multiple classes, the file name should describe the common purpose of those classes. When it comes to folder structure, in purely Kotlin projects, you don't strictly need to mirror the package structure in your directory hierarchy. You can place any package in any directory. However, it's generally considered good practice to follow the Java tradition of matching the package structure to the folder hierarchy. For example, com.myproject.utils would reside in com/myproject/utils folders. This makes code migration smoother, especially in mixed Java/Kotlin projects. To use classes, functions, or properties declared in other packages, you need to import them into your current file. You do this using the import keyword. Let's see how we can use our greetUser function from another file in a different package. Create a new file, for example, package.kt, in a different package, or without a package declaration if in the default package. Importing the function. Calling the function from another package. Alternatively, you can use the fully qualified name without import. Here, we've imported greetUser from com.tonguin.kotlinbasics.utils, allowing us to call it directly by its short name. Kotlin doesn't distinguish between importing classes or functions. You can import any kind of declaration. Your IDE, like Android Studio or IntelliJ IDEA, is often smart enough to automatically add imports when you use a function or class from another package. You can also use wildcard imports to import all public declarations from a package using an asterisk symbol. Import com.myproject.utils, asterisk. Import renaming. If you have declarations with the same name from different packages, you can rename an import to avoid ambiguity using the as keyword. Import com.myproject.utils.greetUser as utilgreet. So, why are packages important? Packages are a vital part of writing readable and maintainable Kotlin code. They help organize large projects into logical and manageable units, prevent naming conflicts, especially when incorporating third-party libraries, control visibility, alongside visibility modifiers, which we'll cover later, as certain elements might only be visible within their module. By effectively using packages, you ensure that your codebase remains clean, structured, and easy for any developer, including your future self, to understand and work with. That wraps up our detailed look into packages in Kotlin. In our next video, we'll dive into Kotlin's next component. So see you guys in the next lecture.